Good morning, pre-calculus. So today we are going to learn matrix multiplication. It's example D because we've already done example A, B, and C. We did the addition of matrices, subtraction, and scalar multiplication. But matrix multiplication, where you multiply two matrices together, is a lot more complicated than scalar multiplication, where you just send a number through. So I made this chart up here, and I will send it to you guys, and I will put it on my Google Classroom. But the key is for matrix multiplication, you want to think across and down. Across and down. So here I have an example of matrix A and matrix B. If I wanted to multiply A times B, I would need to multiply the top row of A by the first column in B. So the A would multiply times the E, plus the B would multiply times the G. Okay, so each one gets its own number. It has its own partner. A goes with E and B goes with G. So the first with the first and the second with the second, and so on and so forth if there were more. So that will give me the top, that came from the top row in the left column, so it goes on the top left space of A times B. Then it's like distributing. So I would give the top row now to the right column. And if there were more, I would keep going, the top row times the columns until all the columns were completed. So again, the A would be multiplied by the F, the first terms go together. The B would be multiplied by the H. And we would add those two products together. And then after the top row has been sent through to each of the columns, it would now be the bottom row's turn. So the bottom row times the left column here, and the bottom row with the right column here. And each letter gets its own partner. The C would multiply with the E, plus the D would multiply with the G. Okay, so this is easier explained. I can explain this more easily with actual numbers. So let's try that. I want to use the definition of matrix multiplication to find A times B and B times A. So I'm asking for both because they are not the same thing. Matrix multiplication is not commutative. It's not like with regular multiplication where 2 times 3 is the same thing as 3 times 2. A times B is not necessarily going to be the same thing as B times A. Okay, so again, I said I want to give my first row to my first column. All right. I will set up some parentheses. The 2 will multiply with the 1. 2 times 1 is 2. Plus the 0 will multiply with the negative 3. 0 times negative 3 is 0. Plus the 1 will multiply with the 0. 1 times 0 is 0. And that's it for the first. That's the top and the left. So it goes on my top left. You got it? Each one gets its own partner. It's not like the 2 goes with the 1 and then the 2 goes with the negative 3. It doesn't work like that. The 2 is with the 1, the 0 is with the negative 3, the 1 is with the 0. And we want to add in between the products. Okay? Now I want to send my first row to my second column. I will start a new set of parentheses. Again, each one has its own partner. The 2 times the 2 gives me 4, plus the 0 times the 1 gives me 0, plus the 1 times the negative 2 gives me negative 2. So I can write that plus the negative 2, or you could just write minus 2, whichever is your preference. But that was the top row and the right column, so it went on my top right. So now that I have sent the top row through everything that B has to offer, it is now time to go to the bottom row. And I will do the same thing. I will just distribute the bottom row to the first column and then the bottom row to the second column. So the bottom row to the first column, I'll come down here because this is the bottom, and it was the left, the bottom left, so it's going to go on the bottom left. We can't just put it anywhere. The 1 multiplies with the 1 and gives me 1. the 4 multiplies with the negative 3 and will give me negative 12, or you could write plus negative 12. The negative 3 multiplies with the 0. Negative 3 times 0 is 0. Okay, just one more. I want this bottom row times the second column now. And that will come down here, bottom, and it's the right. Okay, the 1 multiplies with the 2. 1 times 2 is 2. The 4 multiplies with the 1. 4 times 1 is 4. And the negative 3 multiplies with the negative 2. Negative 3 times negative 2 is a positive 6. Almost done. I need to simplify this. I need to see what AB actually is. AB. All right, so 2 plus 0 is 2. 4 plus 0 take away 2 is also 2. 1 minus 12 plus 0 is negative 11. And 2 plus 4 plus 6 is 12. So my final answer is 2, 2, negative 11, 12. Oh, I forgot to mention, before we even began multiplying these matrices, we should have looked at the order of the matrix, meaning the size, right? Matrix A was a 2 by 3, because when we name its size or its order, we go by how many rows it has and then how many columns. So matrix A was a 2 by 3. It was 2 deep and it was 3 across, right? Matrix B, its order, its size was a 3 by 2. It was a 3 by 2. When I multiply matrices, their middles have to match, like the 3 and the 3. That's what I meant by the middles, the numbers in the middle. If they are the same, then they can be multiplied. If they are not, if this was a 3 and this was a 4, then I would not be able to multiply these two, and A times B would just be undefined, okay? But because the numbers in the middle match, I can cancel those out, and the size of the answer should be whatever the first and the last term was. So a 2 by 2. I multiply a 2 by 3 times a 3 by 2, my answer should be a 2 by 2, a 2 by 2. And that is exactly what AB is. So let's keep that in mind. Before we even start, we want to make sure it's possible and see what size the answer would be. Okay, I'll be back for B times A.